So this is about a potato that's taken out of the oven and left to cool in the kitchen. So the potato starts at 91 degrees Celsius at time zero. And they tell you that over and over again in this problem as though you're going to forget. So it starts at 91 degrees and the internal temperature is greater than 27 degrees for all times. And the internal temperature can be modeled by a function with this differential equation. So this is the rate. H of T, so using H for heat, is modeled in degrees Celsius. And then they tell you this again, H of 0 equals 91. All right, so that's a lot. Letter A, write an equation for the tangent line at time 0. Use it to approximate the temperature at time 3. All right, everybody, question for you. What two things do you need to write an equation? They're asking us to write an equation. So what are the two things that we need in order to write an equation? Good, nice job, guys. Perfect. Point and slope. All right, so we need a point and we need a slope. So the point is 0, 91. They gave us that. This is time, and then 91 degrees is the temperature. Slope comes from the derivative, which is this right here. Now, this is where this is a little tricky. Usually you plug in the x value, or in this case, t for time. But this is in terms of h. H is heat. That's the 91 degrees. So we're going to plug 91 in for h to get our slope. This is your rate. dH dt is the rate, that's the slope. So plug in 91 for that. Technically, you can leave it like this if you didn't want to simplify that down. I'm going to, just for the sake of making this look a little nicer, 91 minus 27, that'll be 64. And then times negative a fourth will be negative 16. So this is our point. This is our slope. I'm just going to write the equation. I'm going to use h and t since that's what they use. If you use x and y, they'll still give you points. I'm just going to use h and t just to be consistent with them. So h minus 91 equals negative 16, t minus 0. And again, if you use x and y, they're still going to give you points for that because you wrote the equation. And then they want you to approximate the internal temperature at time 3. All you have to do is plug in 3 for time and then get h by itself. So I'm going to add that 91 over. So negative 16 times 3 minus 0, just still be 3. And then add over the 91. You can leave it just like that. That's fine. It's degrees Celsius. They did not say indicate units of measure. So even if you left that off, you would be fine. So they were asking for this equation, and then they were asking for the approximation of the potato temperature at time 3. All right, part B, find the second derivative and determine whether that answer is an underestimate or an overestimate. All right, here's what this means. Second derivative tells you concavity. So if you have a graph that is concave up, so upwards like a smiley face, and you draw in a tangent line, the tangent line is going to be below it. So concave up means that you have an underestimate. And if your graph is concave down and you draw in a tangent line, the tangent line is going to be above it. So concave down means that you have an overestimate. So we're going to find the second derivative at this point, this 0, 91, and see if it's concave up or concave down, and that will tell us whether we have an underestimate or an overestimate. So first thing I'm going to do is rewrite this dH dt, and you don't have to do this. This is like a personal preference. I just kind of prefer it written this way. I'm going to distribute the negative 1/4 into there. It would be negative 1/4 h plus 27/4. And we're going to do the derivative of that. So it's the derivative of the derivative. We're finding the second derivative. So this would be negative 1/4 dH dt. 27/4 is a constant, so that would be gone. And then you're going to replace dH dt with this. If that feels redundant, that's because it is. It's kind of silly, my opinion. All right, so it's negative 1/4 times dH dt, which is this. Negatives are going to cancel, and you've got, what is that, 1/16 times h minus 27. Now, we want to look at the second derivative at this point, 0, 91. So we're going to plug in 91 for h. So when h equals 91 degrees Celsius, the second derivative, and I guess we don't need to figure it out exactly, we just need to figure out whether the second derivative is positive or is negative, because we're just trying to decide concave up or concave down. So if you plug in 91 for this, this is going to end up being positive. So when h equals 91, second derivative is positive. So the graph is concave up, and this is an underestimate. All right, so again, concave up, your tangent line is going to be below the graph. That would be an underestimate. Concave down, tangent line is going to be above it. That would be an overestimate. So we found the second derivative, and we plugged in 91. When the heat is 91, second derivative is positive, so the graph is concave up, and this right here is an underestimate. All right, and then like I was saying, part C actually doesn't have anything to do with the rest of the problem because they introduced this totally brand new function, this dg dt. So g satisfies the differential equation, and then they give you that still degrees Celsius, and still this initial condition 091. They just made this different differential equation based on the find the expression for g. So we're going to solve the differential equation and then plug in 3. All right, so first thing is separate the variables. I'm going to choose to leave this negative where it is. I'm going to leave that on the right side just so I have less to mess with when I move this over, but we're going to separate the variables. So this is going to get divided over. This g minus 27 to the 2/3, that gets divided over. So when you move it over, it's going to be to the negative 2/3. So when you divide that over, it would be in the denominator. It's going to be g minus 27 to negative 2/3 dg equals, and I left that negative there. In fact, I'll just write it as a -1, and I'm going to multiply over the dt. So that is separating the variables. And then we're going to do the antiderivative. Now you can write out a u substitution if you want here, but the derivative of a variable minus 27 is just going to be 1. There's no like coefficient multiplied onto the g, so it's not going to change anything. We're just going to add 1 to the power. So negative 2/3 plus 1 would be positive 1/3, and then the reciprocal of that goes out front. So again, you add 1 to the power and then divide by that. And then over here, antiderivative for -1, that would be negative t, and then plus a constant. So we're going to plug in 0 for t, so that's good, that's gone. And then 91 for g. So 91 minus 27, that gave us 64. 64 to the 1/3, that means cube root of 64. So cube root of 64 is 4, and then 4 times 3 is 12. So c is 12. I'm going to recopy this line and put the 12 in for c. And then we just have to get g by itself. So first divide over the 3. And then to get rid of the 1/3 power, which is really a cube root, we're going to cube both sides. And then we're going to add over the 27. So it's going to be negative t plus 12 over 3 cubed plus 27. So that is your equation. And then they wanted us to plug in 3. So at times 3, this would be, and you don't even have to simplify this down, negative 3 plus 12 over 3 to the 3rd plus 27 degrees Celsius. Just leave that alone. I wouldn't bother with it. If you did go further, what would that be? That'd be 9 divided by 3 is 3. 3 cubed is 27. 27 plus 27 would be 54. If you went the whole way simplifying it, you'd have 54 degrees Celsius, but you don't need to do that. All right, points for this one. If you found this one difficult, so did everybody else that took this exam this year. I feel like the only maybe sort of easy part was part A, if you wrote a point and a slope. You get a point for getting the slope. And again, you didn't have to simplify it down. So if you got here, you got that point. You get a point for writing out this equation, and then you get a point for plugging in 3. So that was worth 3 points. And if you got those 3, I'm proud of you. If you got even 3 points out of this, because this was a tough question. Part B was just worth 1. So you had to do all of that. You had to find the second derivative and write out this explanation. And that was only worth 1 point, which was kind of good in a way, because if you got stuck on it, it was only worth 1 point. All right, and then solving this differential equation, it was a point for separating the variables, a point for doing the antiderivatives, a point for getting that C was 12, a point for solving it for G, so getting G equals, and then a point for plugging in 3. Making sure I added all that up to 9.